So according to the information given to us in this question, it says that the lead shots start from rest, so that means that the velocity initial of them is 0 meters per second. It says that the height of the building is 71.3 meters, so that means that the change in y, or the height of the building, is 71.3 meters. And then it says that they are in free fall whenever they are dropped at the top of the building, and that means that the acceleration of those lead shots are at 9.8 meters per second squared. Now it also tells us to determine the speed of the lead shot first. So we're looking for the final velocity of those lead shots before they hit the water at the bottom. In order to find that, we would use the equation velocity final equals v naught t plus a times the change in time. Now the velocity initial is 0, so this portion of the equation goes to 0, so we just use acceleration times change in time. We know the acceleration is 9.81 meters per second squared. However, we do not yet know the change in time, so we first have to find that to plug that back into this equation. To find that, we would use the change in height equation, which is delta y equals v naught t plus 1/2 a times change in time squared. This portion of the equation again goes to 0, so we're just dealing with the 1/2 a times t squared equation. That we know the change in height, that's 71.3 meters, plug that in, equals 1/2 times the acceleration, 9.8 meters per second squared, times t squared, which is what we were looking for. So 1/2, or 9.8 meters per second squared divided by 2, is just 4.9. So I just went ahead and wrote that here instead of rewriting this. And then you, in order to separate t and get it by itself, you have to divide both sides by 4.9 meters per second squared. Did that on both sides. So when you take a height, or 71.3 meters, and you divide it by an acceleration, the meters divided by meters cancel out, and then you're left with seconds squared. So we get this value becomes 14.55, and we're just left with seconds squared equals t squared. Now in order to get t by itself and seconds by itself, you take the square root of both sides. So that would give us, and the square root and the square on both sides cancel out. So you're left with just the value, just the single units, and just this variable. So that altogether gives us t equals 3.81 seconds, which we can then plug back into this equation, and that would be 9.81 meters per second squared times 3.81 seconds. The squared of this acceleration and the seconds of this time cancel out to give the velocity final of 37.4 meters per second. Then the last question asks us, what was the velocity average of the bullet? Well, to find the velocity average, we use this equation, which is, it's the second velocity, or the final velocity, plus the initial velocity divided by 2. Well, we know the final velocity now, we solved for that, but the velocity initial was just 0. So you just divide 37.4 meters per second and divide it by 2, which is the average of the two velocities, and that gives us 18.7 meters per second for the velocity of the bullet before it hits the water at the bottom.